So you're already insulin resistant, you are overweight. What's happening within your body is that your cells are so full. They are so full of substrates and fuel that it can't take no more. Going on a keto diet is a great option because it also regulates your hunger hormone so that you are full easily from the fats and proteins rather than letting the glucose really run your hunger hormones and let you feel hungry all the time. And then you'll start seeing weight loss because your body is starting to self-regulate and start burning all the sugar as well as the fat. BHB is usually the main form of ketone that is being transported around the body because it's the most stable, and it is also the form of ketones that is being used for energy. I literally say I don't care how you get into ketosis as long as you get there and stay consistent. If you can get there via the diet, great. If you can get there via fasting, great. And if you don't want to have to diet and fast and you want to do exogenous ketones, sure, great. Go back to what your goals are. Use it as a tool. Use it as your best friend to help you reach the dreams that you never thought of reaching.
Latt, I want to start out really general here, talking about what ketones are and why they're important for human metabolism.
Sure. Let's jump straight into Ketone 101. This term has been thrown around for a bit, and a lot of people thought it's a new molecule or a new pharmaceutical. It is not. It is actually a molecule that it has been around for as long as early organisms that can metabolize fat. So it is a very ancient molecule, if you would, that we as humans and other mammals or other animals which can metabolize fat has been able to produce in our own bodies whenever we are low on glycogen or when we're low on glucose. So the whole idea of ketones is essentially breaking down fat into smaller molecules so that it can bypass the blood-brain barrier and enter our brain for metabolism. So our brain normally uses glucose as a fuel. However, there are moments where we are low on glycogen or on glucose, like when we're fasting, when we are having a keto diet, which restrict our carb intake in modern day society. That means, our body will start making ketones from fat in our liver and then transport it to our brain. And then if you look at it from an evolutionary point of view, hunter-gatherer sort of human beings back in the day, there will be time where they will go through famine, they will go through fasted state when foods are not available, and therefore they need some form of sustenance and fuel in order for their brain to function, but also in order to put them in a cognitively alert state so that they can hunt for more food. So that's what ketones are. It's a smaller molecule that is derived from fat that our body needs in order to produce ATP, which is the energy form in our cells.
Okay, so fatty acids can't get into the brain. We have the blood-brain barrier there that doesn't allow them through. Any other areas of the body where fatty acids can't get to?
Generally, no, because it's the blood-brain barrier that is the main thing that blocks the bigger molecule from getting into the brain. But most, I think the biggest organ that uses the most energy, apart from the brain, would be muscles, and fatty acids can easily go into muscles and get metabolized.
Okay, any idea why evolutionarily the brain, obviously there's other things besides energy that the blood-brain barrier can protect from, but why would we evolve in such a way that would limit the fuel that could get to the brain? Any ideas?
I would just take a guess here. I don't know for a fact why that is, but I'm thinking that because the brain is such an important organ, that evolution essentially tries to protect the brain from any big molecules because it wants the brain to operate as optimal and as efficient as possible, and therefore only smaller molecules which provides direct energy and fast energy are allowed in. That's my take on it, but I'm sure there is a more interesting evolutionary tale around it.
And where this becomes really interesting is when there's insulin resistance. So metabolism of glucose in the brain is impacted and the rest of the body. and energy production starts to dip, the neurons in the brain don't directly need insulin to bring the glucose in. It's a little bit different there, but insulin's still important with the metabolism. So let's talk about, because of this unique area where fatty acids can't get into the brain, when somebody is having problems with energy production of glucose, insulin resistance, ketones become even more important.
So glucose gets transported into the cell via glucose transporters, or GLUT, G-U-L-T. That's what they call it. GLUT4 specifically is insulin dependent. So there are GLUTs that are insulin dependent, and there are GLUTs that are not insulin dependent. So as you said, some of the cells do not require insulin in order to bring in glucose. And there are other cells, there are other organs that has more GLUT4 that are more sensitive to insulin, because it needs a high amount of glucose in order to be metabolized to form fuel, to form energy. Now, in this case where insulin resistance is present, these organs or these cells are essentially resistant to insulin, meaning that it is not responding to the insulin. It is not translocating, it's not bringing in all these transporters up to the membrane where it can receive the insulin signal in order to bring in more glucose. So what happens then is energy deficit, right? You are having a cell that is starving, even though the rest of your body has high glucose. So you have high blood glucose, for example, in type 2 diabetes, you have a high level of insulin resistance where you have high level of glucose circulating your body, but your body, your different organs are not taking it in, because the cells are essentially saying that I am not taking it in because I am refusing to acknowledge the signal from the insulin. So this is a situation where you are creating a starvation situation amidst all the abundance of energy source around you. And that's when ketones come to play a bigger role, because ketones are not dependent on insulin and ketones are not dependent on GLUTs. So ketones get into the cell via monocarboxylase transporters, or MCT, which is not to be confused with the medium triglyceride fatty acid chain, medium chain triglycerides, which are the fatty acids. Now, if you think about a good analogy or scenario is when you have a traffic jam and you need to get to a place, and what ketone is providing essentially is another route which you can take to get to that place and bypass that traffic jam. And this is what ketones are. It's an auxiliary fuel that is providing your body, especially in people with insulin resistance, because of the deficit in energy as well as the deficiency in glucose metabolism.
If somebody is in that insulin resistant state, how different is their production of ketones versus somebody that's metabolically healthy?
I think that falls down to, one, metabolic flexibility, and two, falls down to the lifestyle, right? To produce ketones, like I said earlier, you need to be on really low carbohydrate and low glycogen, because insulin shuts down ketone production. So in order for you to produce ketones, you need to maintain low level of insulin. Now, the problem with people with insulin resistance is that a lot of the times they have high blood glucose, meaning their insulin system is already out of whack. They are constantly pumping insulin up, and they're having hyperinsulinemia. And because of that, they don't produce ketones as effectively, or rather they completely shut down the ketone production compared to a normal person. If they fast overnight, they might already get some ketone production from that overnight fast, just from 8 hours of fasting. Same thing with the lifestyle, right? So if you are on a low carb diet lifestyle or a keto diet lifestyle, you obviously are more prone to producing ketones versus a person who's on a standard American diet or standard Western diet. So the other point I wanted to bring was the metabolic flexibility. Essentially, it's referring to the ability of our bodies to be able to swap fuel whenever it needs to, depending on the situation that you're in. So if somebody is metabolically flexible, the moment you provide some form of stimulus, either you exercise or you fast or you change your diet, your body will quickly adapt to that change and produce whatever fuel and use whatever fuel that is optimal for that situation. So for example, you exercise and you fast, your body will know that, okay, I'm low on sugar. I need to break down the fat to produce ketones, as well as mobilize fatty acids in order to generate energy to sustain myself. But for people who are not metabolically flexible, their body will have a harder time to switch over. And that's where oxidative damage generates, right? Because you're going against what your body needs. And as a result, it's just ramming the engine without fuel. So you're just slowly breaking the whole system down.
Okay, go into further detail on that. So what I think you're saying, somebody who is metabolically flexible can switch between the two fuels without that damage, versus somebody, say, who is metabolically unhealthy right now, starts a water fast and then pushes through to that point of producing ketones. Talk about that intermediate phase for that latter person and the damage that ensues.
So I'll take an example. So my whole PhD was on type 2 diabetic heart and the metabolism of type 2 diabetic heart. And I looked at the heart's metabolism in hypoxia, which is low oxygen level. So normally a normal healthy heart in hypoxia, when it's low on oxygen, especially, so either you are at high altitude or when you have a heart attack, you have the restriction on oxygen delivery. When that happens, your heart, which primarily would metabolize fat, by the way, about 70% of the energy that your heart gets on a normal person at a normal altitude or sea level, you are metabolizing about 70 to 75% of your energy. You're generating 70 to 75% of your energy from fat, and then the rest from glucose, and a bit from lactate. Now, what happens in hypoxia is that your heart cells start to change it over to glucose metabolism. So it's like a seesaw effect. When you upregulate your fatty acid oxidation, you downregulate your glucose metabolism, and vice versa. So if you upregulate your glucose metabolism, you will lower your fatty acid oxidation. It's called the Randle cycle. So for those who are listening, go Google Randle cycle, Randle. This guy, I think in the 60s, sort of figured it out. When you turn one up, the other turn down. It's a sort of very neat balance system that nature has provided us. So when you are low on oxygen, it swaps over from fatty acid oxidation to glucose metabolism, because the first step of glucose metabolism, which is glycolysis, is independent of oxygen. So it can generate energy independent of oxygen. So even though you are low on oxygen, you are generating energy for your heart to keep beating, because, as you know, our hearts can't stop. So just because you're low on energy, just because you're low on oxygen, does not mean that you have the option to stop entirely. In type 2 diabetic hearts that I've studied, they are very metabolically inflexible. So what we have seen is that they maintain a higher fatty acid oxidation while a lower glucose metabolism is being generated, right? So in that sense, it is still burning fat, but burning fat requires a lot more oxygen. As a result, it is making all this oxidative damage occur, because they are burning fat without the final. So this one is, you have to go a little bit deeper on the biochemical side of electron transport chain, where the final recipient of the electron would be oxygen to create sort of water, right? And when you don't have oxygen there to receive it, that's when the oxidative damage occurs. So similar thing, back to your question earlier, is that you need all these different elements and different components for oxidation, for metabolism, for respiration, the process of creating ATP, the process of creating energy. All these components need to be in place. If one is not in place, then the system switches over to an alternative that is more optimal and efficient. And if the system is not flexible enough and not able to switch over, that's where it starts, sort of the cogs are not in place, and it starts turning against each other and start having that friction and cause each other to run out of a rhythm.
Okay, to zoom back out of the physiology here a bit, is the end goal then to fuel the body in a way where it switches between fat burning and burning of glucose?
Yes, the goal is to ensure metabolic flexibility at all times, because our lives are very flexible. Sometimes you're sprinting for the bus. Sometimes you're walking to work. Sometimes you're sitting down and doing nothing. All these activities will require the different optimal fuel. When you're sprinting for the bus, you will need to metabolize glucose more because you're going into anaerobic sort of zone when you're sprinting. So glucose is better for you to get to that point because it's a fast burst of energy that you need, and then after that you can catch your breath and you can replenish the oxygen that you have been lacking. And if you're just going for a slow jog or a walk, then your body will burn more fatty acids because you have time to take in all the oxygen in order to burn all the fat. And because fat is a much larger pool of storage, of energy storage in your body versus glycogen. So glycogen holds about 2,000 calories in your body, and then fats can hold between 20 to 40,000 calories in your body. So it's a much larger pool to pull from in terms of energy storage. However, the caveat is that we do need oxygen. And therefore, when you talk about cardio zone 2 and aerobic and endurance exercise, you are essentially switching over to fatty acid oxidation, and your body is much better at burning fat. That's why a lot of people, they said, if you want to lose fat, specifically, do more walking, do more cardio zone 2, because yes, it takes longer, but you are essentially forcing your body in that state where you are in the fat burning state. Whereas if you are sprinting a lot, you are building all this fast twitch muscles as well. You are burning more glucose, and you're going for that sprinter physique, but sometimes it does not necessarily burn fat.
Putting the brain aside for now, because we've already talked about how that's a special organ when it comes to metabolism, the rest of the body, how does it decide if it's in a situation where there's fatty acids and ketones?
Yep.
What to use? And then how does the body decide when to make ketones out of the fatty acids?
Great question. I'll answer the second question first because it's very straightforward and direct. So the body decides to make ketones when we are low on energy, and it has to be when we're low on glucose. So like I said, it has to be low glucose, low insulin situation, and then the body will start making ketones. Now, to the question how can the body decide which one to burn? Is it fat? Is it ketones? Is it glucose? If all three are present? The answer is that your body, in a normal, healthy human being, the body will always choose the most effective and efficient pathway. So, meaning that, like I said, sprinting will automatically go towards glucose metabolism. And when you're just between, I would say, like 90 to 130 heartbeat per minute, then you will sort of start burning fat. So your body will choose on its own based on physiological stimulus. Obviously, your heart rate, your breathing rate, the oxygen in, carbon dioxide out, all these are signals that you're giving your body, right? The way you're moving, the way whatever you do, that is a form of stimulus that you're providing your cells and your biological system to let it know, okay, what situation are we in right now? And therefore, what is the most efficient pathway to maintain energy level and also getting the job done?
Okay, given everything you've said now about metabolic flexibility being the goal, how do you feel about people that are in long-term ketosis?
I honestly, I'm a big fan of ketones, obviously, not just because I work for Ketone IQ, but because I've been taking ketones for 5-6 years now. But long-term ketosis. This is a very interesting question. So are you talking about long-term ketosis while you take exogenous ketones like ketone IQ, or long-term ketosis because you are on keto diet for a long term, right?
Keto
Because
diet long term.
Yeah, because I believe those two are different physiologically. Because if you are in ketosis because you take exogenous ketones, it is transient, it is temporary, and your body is still basically on a baseline level, it's still not ketotic per se, but you have access to all these ketones and this amazing benefits that comes from ketones, especially for your brain and cognition. While if you are on an overhaul of your lifestyle and diet, meaning you're on a keto diet, you are essentially changing your entire lifestyle. You're changing your metabolic pathways essentially, and that's why I say to people, while ketones are great, there are uses in both exogenous ketones and keto diet. There are places where if you need to literally overhaul your system and making sure that you are reversing your insulin resistance, for example, exogenous ketones are not going to be that helpful for you. You need a keto diet to reverse that insulin resistance, because you are overloading yourself with glucose and abundance of calories. Therefore, you need to pull back and let your body adapt to that new norm. So I honestly do not think anyone should be on a specific diet for a prolonged period of time unless you have a certain condition or illnesses that requires you to stay on that diet long term. Because I feel like the body, because we're talking about metabolic flexibility here, right? So what actually gives us the flexibility is to actually give our body the different fuels that it needs in order to maximize and optimize outcome. If you are on a keto diet for a long time, you are essentially starving your body from glucose, which in some cases will be good for people who are insulin resistant, for people who want to lose weight. And then once you get to that goal, I think it will be important for you to allow your body some form of glucose in order to retrain your body to be able to metabolize glucose, because our bodies are designed that way. It is designed to be an omnivorous sort of organisms where we would, eat anything and everything, and we are also designed to metabolize all different types of fuel. While we can function optimally and perfectly fine on just fats and ketones, but over long term, I've seen some anecdotal examples where people's bodies start to go against that. They might have some inflammation problem, they might have some energy problem, or there's some some plateaus of fat loss that they couldn't get rid of because their bodies are so used to fat and store fat rather than burning fat after the initial fat loss phase, that they find it difficult unless they put in some carbs and allow their body to increase the insulin, because then insulin will also play a role in like muscle building, metabolic rate increase and stuff like that.
Okay, I hear what you're saying there. The pushback would be our body can make glucose. Is that not enough for what we need? You gave an example before about sprinting for a bus.
Mm-hmm.
Bring that in.
Yeah. No, that's a great point. Then I can also say, so you see how important glucose is? Even when you do not eat glucose at all, your body is still making glucose, right, at baseline level. So that just shows how important glucose is to our body. My push is not that saying that, oh, you can't survive without glucose. You can certainly do that. What I'm saying is that if you want to optimize further, once you have hit a plateau with whatever your goal is while you are on keto diet, maybe introducing glucose to really switch that up can actually break that plateau. For even when you're training, right, for athletes who are on keto diet, they swear by it and it works for them. But what other changes can you make in order to bring you to the next level? Glucose could be an easy fix. And I'm not talking about like adding 500 grams of carbs every day, right? I'm talking about just adding a little bit just to train your body to be more flexible whenever it needs to be.
Let's talk long-term insulin. Somebody that's on a long-term keto diet, they're not spiking blood glucose or insulin. What happens to that insulin response over time? And then what if they reintroduce carbs down the line?
Great question. I've had that experience myself personally because I've been on low carb for a long time. So when I did the oral glucose tolerance test, I essentially had what they call a reactive hypoglycemia. So I had 75 grams of carbs, and then they measured my glucose and insulin every hour, every 2 hours. What they have found is that my insulin response was great. It shot up right away as the glucose went up. But the problem was my insulin sort of freaked out, and it stayed up for much longer than it's supposed to. Even after the glucose dropped back down to baseline, my insulin was still high up. So in that sense, you are giving your body a shock. And we don't want that, right? We don't want a sustained elevated insulin level because that has been correlated. Now, again, it's correlated. I'm not sure if there's any study that showed causation per se, but it has been correlated with inflammation levels. So my point of introducing carbs back in the diet, like little by little, is to be able to adapt to those situations. Because if you're long-term on keto diet, let's say one day your kid's birthday and you want to have a piece of cake, and then you get to that situation, your body is not able to adapt as quickly or not metabolically flexible enough. So if you train your body to be able to do that, maybe then you can have a piece of cake, your insulin goes up, bring the glucose down, and then you couple it with exogenous ketones. The next day, bam, you're back in ketosis, and then you can continue your keto diet.
Do we know how long that would last? Somebody bringing a modest amount of carbs back into the diet, this effect that you're talking about here with the insulin being wonky, is this just a one-day thing or a week thing, or do we know?
That's a great question. I think it depends from individual to individual. I think the variance is very large from what I have seen, like from people that I've talked to, from doctors that I've talked to. There are no studies that I can find to look at that because I don't think anyone is interested to put people on keto diet and then put them off and then look at all that and then change back. There's no studies on it so far. I think the only way to find out is trial and error and figure it yourself via your blood glucose level, your blood ketone levels, and essentially oral glucose tolerance test. But I think subjectively, certain people can also feel the subjective difference. When I am on low carb and keto diet for a while, the moment I have a moderate amount of carbs, I would crash. I would be so sleepy. It's like as if I took melatonin. That's when I know that my body is not reacting well to it. And that's when I know. So either then at that point you can choose, right? Okay, I'm not going to have carbs ever because it makes me feel bad. Or, okay, I'm going to train my body to be able to handle the carbs better because I know that I go to the gym, every day. I work out every day. I need that energy level from the carbs, and it makes my lifts better. And some people say, oh, I don't need the carbs. My lifts are great anyway. And you can continue on the keto diet. So you can choose. There's no right or wrong answer here. I feel like it depends on your goal. It depends on your metabolism. And it depends on how sustainable it is for you. If you feel like keto diet is sustainable for you and you are getting healthy biomarkers readings, then by all means carry on. But if you feel like you are plateauing, you can't get to your goal, or you are having some form of symptoms that is showing that, okay, maybe your body is needing something else, some other nutrients that you're not getting out of the keto diet, then switch it around.
I couldn't agree more about the goal thing. We definitely have to look at what the person's trying to accomplish. Are they 300 pounds, metabolically unhealthy, trying to lose weight and get their metabolic health back? You've mentioned a couple times performance in the gym. A lot of the people coming to this conversation are just trying to get metabolically healthy again. They don't care about that 5 seconds they could shave off a sprint or putting up an extra 10 pounds of weights on a set at the gym. So agree with you on that. We got to look at what the person's coming in with and what their goals are.
Oh, absolutely. I mean, I worked with special forces where if they get 0.125 seconds on reaction time. That's life and death situation. So they would do whatever it takes to increase that performance, right? Same thing with Olympians and athletes. They would do anything to increase that 2 seconds because that's between a gold and a silver medal. So, but also remember, even as, just non-athlete, non-special forces people, normal folks like us, our goal post shifts all the time. And, let's say you're 300 pounds, you're trying to lose weight. Once you reach to 200 pounds, it does change a little bit, the goalpost. Maybe now it's not fully fat loss. Now, maybe you want to put on some muscles too, because the muscle mass would also help with increased metabolic rate and therefore increased fat burning passively, which makes your life easier. So instead of having to walk 2 hours every day, you maybe have to walk an hour and a half and maybe put some weightlifting sessions in like half an hour, right? So the goalpost change, it stands, the reason stands that your approach should also change with the goalpost, because your body is a very flexible, very malleable thing. And whatever you change to your body, the initial shock value to your body is what you're trying to get here, that your body is like, okay, there's a change here, I need to adapt. And for from our understanding of physiology and biology, we are making those changes that are inducing the adaptation towards the goal that we want to be. Obviously, don't make the change where your body start breaking down, increase inflammation, and then get you sick, right? Don't break your body by inducing too many changes or changes that are not optimal. Work with a coach, work with a dietitian, work with somebody who knows and has done this before. I myself, even though I have a PhD in physiology, I have a personal trainer and he also works with me on the nutrition part, right? So I believe that even if you're an expert, you can learn a lot from others who have done this, many times and through many years.
Let's come back to the performance piece.
Sure.
And give a couple different scenarios. Somebody lifting weights and then somebody doing cardio. And we'll say they're metabolically healthy. They want to utilize the different macros, whether it be fatty acids, carbs, or ketones.
Yep.
How do they go about doing that leading up to the performance?
Great question. So lifts, if somebody is lifting weight, generally we're thinking of anaerobic exercise, because you are having a fast burst of energy. You're lifting heavy weights. You only need that energy for a short amount of time, and therefore you should use more glucose. And people who just go on, don't get me wrong, I know bodybuilders who are on keto diet and they look great, they're doing great. I'm talking about people who just swapped to keto diet and they're not as keto adapted yet, right? So when they lift weights, they can feel the difference. They feel more fatigued much faster. I've experienced it myself when they lift, because they are not able to access the ketones, and then at the same time they're also low on the sugar, and therefore they can't produce that fast energy that it needs under anaerobic conditions. When people are doing cardio, now depending if you are sprinting, you are still also looking at the glucose pathway. But if you're just running at up to zone 3, you are generally burning more fat, and your body will get used to utilizing that fat.
Well, let's bring exogenous ketones in. Having that variable to play with, what would the baseline diet be? You're giving us a bit of a lay of the land here for each of those scenarios, and then having that adjunct and where you'd layer that in to get the best performance.
Yeah. So I would definitely look at your diet as a baseline, right? Like, tailor your diet specific to your needs, first of all, right? If you are on a lower carb or a higher carb, just what makes you feel good to begin with, and stick with that. And then layer that up with exogenous ketones. Now then you are adding the advantage that ketones have on your cognition, on your focus, and on your endurance. So just recently, I was just updating the team today. We just have a study from University of Hawaii that sort of had preliminary data so far. We just submitted an abstract for the American Condition and the Strength and Condition meeting next year. they saw an improvement in critical power. Essentially, is how much of the tank that you have in order to maintain a certain intensity. So for like a 10K, for example, higher critical power means higher running pace for a longer period of time. And that has been shown to increase with ketone IQ. So that's super interesting data, right? Because we're not talking just anaerobic, we're not talking just endurance or aerobic. We're talking about just critical power in general, just that fitness level and gold standard for the intensity maintenance. And so with your diet in place, having that ketones on top is pushing you that extra like 1-2%. And obviously with training, that 1-2% then compounds, because that 1-2% increases whatever you need, whether it's muscle mass, whether it's fat loss. Over time, then your body adapts to that new change and therefore having better performance, 3 months, 3 weeks down the road, 3 months down the road.
When it comes to exogenous ketones, there's a few different types. We have the salts, esters, and then ketone IQ is a precursor to BHB. So let's give a general overview of the 3 different types and then pros and cons.
Sure. So let's go back to the body's ketone first, because the body ketone is the native ketones, right? The 3 types of ketone bodies that we produce within our body are beta-hydroxybutyrate, which is BHB, acetoacetate, and acetone. Acetoacetate, usually you pee out. Acetone, usually you can you excrete it via your breath. So when people are on keto diet and people talk about fruity breath, that's acetone. BHB is usually the main form of ketone that is being transported around the body because it's the most stable. And it is also the form of ketones that is being used for energy. Now, ketone salts are essentially BHB bound with salts, sodium, potassium, magnesium. And it has been around way before ketone esters or ketone diol, ketone IQ. The problem with ketone salt is that you can't get to a high enough level of blood ketone concentrations in order for it to have a significant effect. There are many studies done, and you just can't get to the blood ketone levels between like 1 to 2.5, where you really, really see the significant benefits. And in order to get up there, you need to up the dose. And the problem with upping the dose is that you would then increase the salt load. So either you're going to induce GI issues, having diarrhea and all that because of the increased salt load, or in certain cases like where we've got a study in Aarhus University in Denmark, we are providing 250 heart failure patients with ketone IQ for 30 days. They already published one paper last December, just 1 dose acute use of ketone IQ. They already saw increase in cardiac output and stroke volume and ejection fraction, which are a very, very significant predictor of mortality for heart failure patients. And in these patients, that you can't give high dose of ketone salts because that would just ruin them with the increased blood pressure because of the increased salt load. So there are certain cases that you can't, and plus, since it doesn't work and it doesn't get you to that level, a lot of these ketone salts companies stop calling them salts. If you realize there is a swap in the paradigm where they start calling themselves ketones instead of ketone salts, whereas before they have no problem calling it ketone salts because they know that it doesn't work. And then there is ketone ester. So HVMN brought out the first HVMN is Ketone IQ's parent company, the health via modern nutrition, and we brought up the first ketone ester in 2017. Came out of University of Oxford, the lab that I got my PhD from. And ketone ester is essentially a BHB bound with a butanediol, and that ester bond, that bond between the BHB and butanediol is why it's called ketone ester. And ketone ester has been studied the most and has been showing the greatest results in terms of historical data because it has been around for a longer time, and it is able to increase your blood ketone levels much higher than ketone salts. It goes all the way up to like 3 to 4 millimolar, whereas ketone salt would not even go past 1. But the problem is it drops very quickly as well. After 2-3 hours, it will just come crashing down. But in, I believe, 2020 or 2021, there was a paper that found that because of the sharp increase in blood ketone levels, there is also a sharp increase in blood acidity levels, because BHB is a sort of acid form, and it increases acidity in the blood, and that causes an increase in cardiorespiratory stress biomarkers, like your breathing rate and your heart rate. People just find it harder to work out to get the same results. The reason being because you have high level of acidity in the blood, you are trying now to excrete as much carbon dioxide as possible. So your body is working double time in order to eliminate the carbon dioxide as a form of balancing the acidity in the blood. So that was ketone ester. Plus, it does not taste good, and it was very expensive to produce. There are certain disease therapeutic areas that require very high level of ketone of blood ketone levels. In which case, usually when researchers come to me and ask, and I would say, yeah, go for ketone ester. If you need that high level for that long, go for it, and if you can afford it. For most people, like 99% of the people who do not need that level, that, we're talking, for example, I was talking to a hospital on TBI patients who are unconscious in ICU. Like that kind of level, they need very high ketone levels for maintain for a long time. And then there's ketone-diol. So as I said, ketone ester is a BHB bound with butanediol. We basically took the other half, the butanediol half, purify it, made pure R13-butanediol that converts 100% to BHB in your liver, and that what we found to be more sustainable in terms of blood ketone levels. It peaks about 2 to 3 hours, around 2 millimolar depending on the dose that you take, and it stays above 1 for more than 6 hours. So for most cases, especially for either cognition or therapeutic uses where people need a sustained higher level of ketone concentration in your blood, that works very well. The cost is much lower than ketone ester, and we managed to flavor it much better than ketone ester. Ketone ester, we did have a lot of difficulty trying to flavor it to make it palatable. So it's better PK, better price, and better taste. And also in terms of people being concerned, it's putting burden on your liver, blah, blah, blah. But let's face it, alcohol would put way more burden on your liver. This is literally just converting. It's not even detoxing, right? And it's also, you also have to think about when you're on keto diet, you are also producing ketones in your liver as well. So a lot of people try to discredit ketone-diol because it's being processed in the liver. It is just a process. Our liver processes a lot of things, and it's just one of the processes. Same with keto diet, and I've been taking it for 3-4 years now, since before it went into market, because we tested it on ourselves. Obviously, after we get the FDA GRAS safety profile and everything, we tested it ourselves, measured ourselves, and we felt the difference subjectively ourselves as well. And I measure my blood biomarkers twice a year, monitor my liver and everything. My liver enzyme actually got lower in the past 2 years, compared to a lot of people claim that, it's gonna shoot your liver down.
At this point, what does your diet look like, and how much ketone IQ are you taking per day?
Okay, I'm taking between 30 to 50 grams of ketone IQ. So about 3 to 5 shots of ketone IQ. I take one before podcasts. I usually take 1.5 for morning fasted workout. So one whole shot of ketone without caffeine, and then one with caffeine. So there's 10 grams in the one without and 5 grams in the one with caffeine. So I'll take that before my fasted cardio. I'll take one if I have any podcasts or any interviews, and then I'll take one before workout, and then 2 before bed.
And what does the basic diet look like that is underneath that?
Basic diet. So my diet currently, actually for the past 2 years, I have been on a carb cycling diet. As I said before, I essentially shot myself in the foot with my diet for the past 7 years before I reached, 30, before 10 years ago. So I grew up overweight, right? My late dad had a stroke, passed away from a stroke when I was 17. He had a heart attack before that, a few years before that. My mom's family has high prevalence of obesity and diabetes. I grew up overweight. I've always thought that nothing would change. I would just be overweight like my relatives, like my uncles and aunties. And not until I went into biotechnology for my undergrad in the UK and learning about physiology and metabolism that, I can actually change this. I can change my lifestyle and actually not have to live that same outcome as my relatives. So that was when I started exercising and changing my diet and all of that. But the problem was once I've lost, like about 45 pounds and being in normal weight range, I got paranoid. So every time I lift weights, I start gaining muscle. I saw an increase in weight on the weighing scale. I freaked out. I was like, well, am I getting fat again? So I countered that by eating less. So after 7 years of doing that, I essentially shot my metabolism and gave enough signal for my body to say, okay, you're not eating a lot. So whatever you eat, we are going to store it as fat. Because that is the most, we can store more fat than glycogen, like I said earlier. So what happened was I can always be like in a healthy range, a healthy weight range, and I can be quote unquote fit, but I can never get to the next level because of that. And for the past 2 years, I've been working with my coach, Jay Ferrugia, and he introduced this carb cycling method to me. And I was so pleasantly surprised how it worked. I was on low carbs most of the days. And when I say low, I'm not talking about 50 grams. I'm talking like 120, 130 grams of carbs a day. So it's like moderate carbs, right? And then about 1 gram per pound of body weight protein. So about 180, 185 gram of protein. And then about 30 to 40 grams of fats. And then obviously go for, whole foods. I'll go for like steaks, chicken, vegetables, berries, white rice, potatoes, rather than, processed foods, if I can avoid it. Unless I eat out with friends, then, I'll order something that sort of fits that category. So that's my diet. And then once a week, I would up my carb intake from 130, 120 to 400 to 500 grams. Just one day. And I was like, why are we doing this? Like, why am I like forcing my insulin level high? And I know my body can't handle the insulin level. Like, why am I doing? He's like, just trust the process, right? A few months down the road, I was doing that same workout, same routines, same diet, started shredding fat. I started losing, I've lost about 30 pounds of fat because I measure with in-body. My muscle mass has maintained and I've lost 30 pounds of fat without compromising my muscle mass nor my strength, which is more than I can ask for because I was expecting, okay, I'm going to lose some muscles when I lose fat because I'm on calorie deficit. That's physiology, right? Calorie in, calorie out. You have less calorie, your body will start burning everything. But I managed to maintain my muscle mass with the strength training that he prescribed me 4 times a week. And then a lot of walking. And then the carb cycling diet just allows my body to, or allow me to retrain my body to metabolize glucose, to be able to be more flexible metabolically, as well as telling my body that, hey, we have abundance of food and fuel now. You can start working normally according to your stimulus, which is building muscle and burning fat, because that's what I've been doing, right? Lifting weights and cardio. So that is the stimulus that my body needs in order to tell it what to do. I'm basically just matching my nutrition to the stimulus that I'm providing.
So by the sounds of it, given your macros, you wouldn't be producing any ketones on your own at all at this point.
Correct.
Talk about that.
So I would assume I'm not producing any ketones at all, because even on my lower carb day, it's more than 100 grams of carbs, which means there is some form of insulin response in my body. And because of the presence of insulin, it will shut down my ketone production. But that's not my goal, right? My goal is not producing ketones. My goal is burning fat, regardless whether or not I'm producing ketones. So if I can achieve my fat loss goal, and again, my goal is also retrain my body to be metabolically flexible so I can tolerate carbs more. So what happened when my body was not metabolically flexible? I cannot tolerate carbs, right? So whenever I have carbs, I gain fat. And while I can maintain that low carb lifestyle for as long as I want and I can be fit during that time, there will be times where I'm on holiday, where I'm with family, where there are festivities, that is inevitable that I eat some carbs and then it turns to fat, and it brings me back to like almost square one. It takes a much longer time to get back to my fitness level per se. And so now I don't have to worry about that anymore. That's not stressful for me anymore. I can go on holiday for 2 weeks and just watch roughly what I eat. I'm not going to track everything, obviously, but I just watch roughly what I need in terms of macros. And I'll come back. Maybe I'll gain 1 pound or like lose 1 pound. But within a week, I'll get back to where my level was. That, to me, is something so new and I'm so excited about, because my body has never done that. I would gain weight and it will take me a month to get back where I was, because my body was so resistant to being fit. It is because your body is not designed to be fit. Your body is designed to prioritize survival. And because I was on low carb and low calories all the time, the best survival tactic is to hold on to the fat. It's not to be fit, because fit means I'm increasing my metabolic rate and I'm burning more fat and burning more calories in general. And I might burn off my proteins and my muscle mass as well. So my body was holding on to the fat. But right now, what my body has changed to is it will prioritize fitness and high metabolic rate, because it can now count on me to provide all the sustenance that it needs to maintain that high metabolic level.
It's interesting because you're in a really unique position, having up to 50 grams of this molecule that's turning into BHB in your body. If it weren't for that, do you think you'd still be on the same diet?
I think the same diet would still work. It might be less efficient, because just this year in July, if you search Professor Bina Zhou, Binajoe, from University of Toledo, she published 2 papers this year on rats and mice, I believe, and animals, in rodents, using ketone diol, using iron-3-butydiol, which is the active ingredient in ketone IQ. And she saw, 1, it protects the kidneys, and 2, it has epigenetic effect, meaning that it turns on certain genes and translates it into protein synthesis that turns up certain pathways. And these pathways that are being affected are all, most of them, related to fatty acid oxidation, which is super interesting. Meaning to say, if you have ketones in your body, over time, you are turning on all these genes that are increasing your fat metabolism and fatty acid oxidation pathways.
Which brings me to pathways in general. Somebody that is on a keto diet, they've been on that long term, their metabolism is going to obviously change, versus somebody who is a carb burner, putting ketones in on top of that. Talk about how the metabolism is different there, and then the difference between somebody using exogenous ketones in both those cases.
I think for a carb person taking exogenous ketones, obviously that effect, 1, is more transient, and then 2, is probably less significant. Even if we're talking on an epigenetic level, you need to maintain that for a prolonged period of time in order to see even something more significant in terms of fat burning. Versus somebody who are on keto diet, obviously without any glucose at all in your body, you will start burning the fat. So the effect of fat burning, you'll probably see a bigger weight loss at a much faster rate. For example, I just said I lost like 30 pounds of fat in 2 years. Somebody, like you can see on social media, a lot of people can do that in 3 months, right? Depending on how big you are. If you're like 250 pounds, like losing 30 pounds is nothing, right? If they're on a strict diet, on a strict regime, like they can lose that in 3 months. I wasn't aiming for that because what I knew my body can do that, but it'll bounce back right off, and it'll take me 6 months more to get back exactly where I started. So I wasn't aiming for that. I was aiming for something more sustainable. I'm aiming for a new body that recognizes the lower body weight as my new norm. So that was why I was doing what I was doing. And then introducing exogenous ketones on top of that. So for the carb people, I already explained. So the effect is transient and all that. If anything, it's more on the cognitive and productivity side. So, okay, you're on the carbs, you're lifting weights, you're doing your cardio, you're training very hard and consistently. The ketones will add the value that the ketones will add will be more on the focus, on the energy level, on the motivation, in terms of, it will provide energy for you. A lot of people, they find, especially in the morning workouts, they find it very useful. So that just gives you more push towards the consistency, because ultimately no supplements can change your life unless you are consistent with lifestyle, both the activity, the nutrition, your sleep, your stress, all of that, right? That has to be consistent first before you take any supplements, because supplements, unless if it's Ozempic, right? Unless it's pharmaceuticals. And then the keto diet people on exogenous ketones. So a lot of people would argue, hey, why would I need exogenous ketones when my body is already producing ketones? I want to burn my own fat to produce ketones. That's right. And if you can get into consistent ketosis without the help of exogenous ketones, great. Carry on what you're doing. But there are people who find it hard. They yo-yo between their ketone levels. They know that there is a inconsistency for whatever reason. Either their diet is not consistent or their metabolism is out of whack, so their body can't maintain ketosis for a sustained long amount of times. Then they use exogenous ketone to sort of supplement that. What we have also seen is that when you take exogenous ketones, not only on an epigenetic level, on an acute level, it upregulates all the enzymes related to ketone metabolism. So if you are on a keto diet already, you are just boosting your efficiency in metabolizing ketones by taking exogenous ketones.
Do you find that people who are on the verge of going into ketosis with the diet, who have a shot of ketone IQ, that can sort of prime the pump and get their body producing ketones on their own if they do that initially?
Yes, absolutely. In fact, we have a whole, I think, blog post showing how ketone IQ could also help people to get through the keto flu when they first start a keto diet and their bodies are not used to being on ketosis, not used to losing all those glycogen because there's less glucose, and they're losing all these electrolytes and therefore feeling like they're coming down with the flu. Then having exogenous ketone during that period of time helps them maintain that level of cognition, that brain fog, and energy level until their body gets used to the keto diet and get more keto adapted.
I want to give a hypothetical situation here to understand the physiology. Somebody who is metabolically healthy, we'll say they go on a water fast, just to make the variables more simple here. And they are loaded with glycogen. They have a normal blood glucose. They're not used to being in ketosis. Walk me through the first few, say even up to 5 days, the changes that happen in the body and the production of ketones as their metabolism starts to transform.
Now, are they fasting for 5 days?
Yeah, water fasting, just to make it simple. We could say 20 grams of carbs and they get into ketosis that way.
Right.
I'm just using water fasting to eliminate a variable there.
Right. No, that's fair. First of all, I have to say fasting for 5 days is crazy and it's really hard, and I respect those who can do it, because I tried a 72 hours and it was hard enough. And I did it almost like cheating. because I was still having ketone IQ. Because ketone IQ does not break your fast, it does not increase insulin levels, and therefore, even if you are not going for the ketone production, if you're going for autophagy, for example, it will not stop that from happening because it won't break your fast. Same thing with the fast mimicking diet. If you search, there are a lot of studies using the fast mimicking diet by Dr. Voltalongo. They have between 500 to 700 calories a day, and they still manage to mimic fasting. So that was quite interesting. So somebody who's metabolically healthy, they go on a water fast. Within 24 hours, you'll start making ketones already because you will have depleted most of your glycogen and glucose. So you start having, more than 0.5 ketones, 0.5 millimolar in your blood ketone levels. And then around like 36, 48 hours, your body will start going through autophagy, cleaning out, all the debris and whatnot. And then it's not that your body is like keto adapted, but your body, like I said, it is naturally designed to create and metabolize ketones. So your body is if this person is metabolically flexible, it will automatically switch gears into fat metabolism and also ketone productions, and then it will start burning all the storage. Right, once it finishes all the glycogen, it'll start burning fat. It'll start really upregulating all these other pathways that are essential for survival. To a certain point, I believe I can't remember after how many hours, but to a certain point, it will start burning your proteins, and you'll start seeing proteins in your pee, which you shouldn't see, because your body then, it's like using everything and anything in order to survive. So that's the process here. Now, if you ask me after that 5 days, would that person then be considered as keto adapted? I would say if they're metabolically flexible, they are sort of keto adapted anyway. If they're on if you put them on a keto diet, they shouldn't have much problem. But most people nowadays, especially we know in the US, 92% now is metabolically unhealthy. So most people are not metabolically flexible, and therefore, you will need a longer period of time to let your body adapt to a keto diet in order to be keto adapted or efficient at, metabolizing ketones.
Given that current situation of how metabolically sick we all are right now, would you say the average person is ever producing any ketones?
No. I would say most people in modern society are not, because of the amount of sugar and calories that we're consuming and the processed foods. Processed food per se, if they're like, low in carbs, maybe you will still produce ketones, but generally they are high in sugar, or not even high, even moderate level of sugar. Like I said, like myself, like 100 grams of sugar a day, 100 grams of carbs a day, it's enough to shut down ketone production. So unless you're actively going through a keto diet or a fasting period, it's very unlikely that you're producing your own ketones. That's why sometimes every 6 months or so, I'll do like a 24, 36 hour to 48 hour fast just to have a little reset of the body and just keep it more flexible, really. They always say, keep your body, keep your body on its toes. Be unpredictable.
Putting exogenous ketones aside, what about things like MCT oil, other supplements people can use to hack ketosis?
So MCT oil has been shown to be beneficial, at least in Alzheimer's. There were quite a few papers published and case studies published using MCT for Alzheimer's, and it has been, quite useful in the mildly cognitively impaired individuals as well. But for some reason, it hasn't really gone through to the mainstream. I think the main reason is that, one, it does not raise your ketone levels to a high enough level. It's very comparable to ketone salts, actually. And two, it also does cause GI issues. I don't know if you've taken it, MCT. If you take too much, you do have the runs. with MCT.
Yeah, I've experienced that. I think
Yeah,
it's pretty
so I
common.
think that's the drawback there, and especially with Ketone IQ coming into the market since 2022, a lot of people find that it is a much better alternative in terms of, one, the reliability in raising blood ketone levels, and two, the absence of GI issues.
What about other supplements? Anything else in that realm that people are using?
For ketosis, I think, let me think. I mean, we talked about ketone salts, we talked about ketone esters, and then there is MCT. There are some new ones coming. Some new ones that are trying to get into the market. Free BHB, or they call it free acid BHB. It's basically pure BHB, and people and they play on, or they either play or prey on people's naivety or people's lack of understanding of the science, because they're like, well, we want to raise blood BHB, so surely you want to take the pure BHB, and logically, rationally, the rationale is sound, right? You want to raise your blood BHB, so you take the exact molecule, which is BHB. However, they did not tell people that the reason why ketone ester was invented in the first place was because free BHB does not work as well, because you need a high level of BHB, you need a high dose. But the problem is it is in its acid form. Imagine ingesting acid directly. We've tried that in our studies with SOCOM. I myself have ingested it myself to test it. It was bad. It was like drinking acid, right? So you'll have acid reflux, you have heartburn. One of our researchers, she almost died because we had the same dose as the ketone ester at that point, which was very high. And she was like, we're not continuing with this study. It is impossible for people to drink this. That's why ketone ester was created, so that it can enter your body and then get broken down into BHB and butanediol, and then butanediol goes into your liver and get processed into BHB. Same thing with ketone IQ. It goes to your liver, and your liver acts as that barrier and also as a measurement, so that it doesn't produce too much BHB. So the problem we had with ketone ester, as I said, it spikes your BHB too quickly because half of it is BHB. So there is no gatekeeper there. So it breaks down in your gut, and then half of it, the BHB, goes straight into your blood. The butanediol goes to your liver, and nothing is stopping your blood ketone levels to go so high that you are acidifying your blood. Whereas ketone like ketone IQ, it goes to your liver, and it is being gate-capped by the liver. So the liver is getting signals from the rest of your body, is saying either, hey, I have enough energy, stop converting it into BHB, converting it slower, or hey, I've got enough ketones. So we've run our internal study, and an increased dose, even at the highest dose, people are not getting blood ketone levels above 2.5, which is a good thing, because just because something is good doesn't mean more is better. There's this mentality we have here in the US. Oh, when something is good, more is better. Let's look at money, right? Having money is great, but more doesn't mean better. You see the miserable people around here, and how, same with vitamin C, right? Vitamin C is great, antioxidant, right? More does not mean better. You're going to end up peeing a very expensive pee, right? So everything about metabolism is a optimal zone thing. It's always a oscillating wave where you need to just maintain it within that optimal zone. You don't want to shoot it up too high, and you don't want it to crash too low.
Well, keeping what you just said there in mind, what about complements to exogenous ketones? Things like caffeine. You mentioned before there is actually caffeine in one of the shots, depending on what you end up getting.
Yep.
So talk about the interaction there, and then other substances that have a good synergistic effect with ketones.
Great. Okay, let's talk about caffeine first, because caffeine is out there already. So I take it in the morning for my fasted workout because I need to wake up and the caffeine sort of kicks in. But I also personally can't handle a lot of caffeine. I get headaches. If I have coffee, I don't drink coffee. I don't drink Red Bull. It gives me a headache. Like that level of caffeine is just too much. Whereas one shot of Ketone IQ with caffeine is only 100 milligrams of caffeine from green tea, and then 5 grams of ketone. So that gave me a lot of synergistic effect for my workout in the morning. Some people, however, they love their coffee. They love their morning coffee. They can't live without, right? So they stick with their coffee and then they take the non-caffeinated ketone. So they're still mixing caffeine and ketones and having the same effect, but it's just at different sources. People use it for pre-workout, caffeine and ketones. That's perfectly fine. If you think about it, caffeine is a stimulant. It increases your heart rate, it increases your blood pressure. It really stimulates your brain activity and your overall sort of metabolic activity, right? However, it is not a fuel source. It increases your activity. Where are you getting the energy from? You are still drawing the energy from within your body, all the fuels, all sources and storage within your body. Ketones, on the other hand, is not a stimulant. And it directly provides the fuel source that your body needs. That's where it synergizes, right? One increases activity, the other provides the energy that you need for the activity. Other substances, I feel like I'm going to get into trouble because I'll say something that in studies that we have seen to be synergistic, but our regulatory people are going to be like, you can't make those claims yet until we have approval from FDA. But I can say I myself use it. I use before bed with melatonin and L-theanine, and it helps me with my sleep. What else? There is a theory, I'm talking about theory, there's no study so far, that psychedelics may also work well with it. We are talking to have a study right now, actually, with one company based in Portland. They're interested to use ketones in their patients who are using psychedelics as treatment because, again, in functional MRI, they saw an increase in brain activity when people take psychedelics. And we have seen that in ketones during fMRI as well, there is increase in interaction between the brain regions. So there is increasing crosstalk between the brain regions, and that sort of network stability increase with ketones, even with just one dose of ketones, which is very, very strong evidence that it could work synergistically.
Interesting. Come back to the sleep piece. Intuitively, ketones wouldn't be something people would think to take before bed.
Correct.
Talk about the science there.
You think about energy, right? You think about energy shot, or like it gives you energy. Why would you take it before bed, when you don't need energy? Technically, you do need energy when you sleep as well, because your brain works very hard during sleep hours because it's consolidating the memories throughout the day, the learnings and all of that, right? And your muscles are recovering. It's building your blood vessels and your muscle fibers, rebuilding all of that during sleep and during rest. So your body does need energy. But why ketones are not going to interrupt your sleep is that, like I said earlier, it's not a stimulant like caffeine. Caffeine works specifically in blocking your receptors so that you don't feel fatigue, so you don't feel tired, and therefore it will affect your sleep levels. Your sleep quality. Ketones, on the other hand, because it's just a pure energy source, your body can use it. It does not necessarily keep you awake per se. Now, my take to, my protocol to take it before bed is literally take it right before bed. If I take it like an hour, 2 hours early, yes. And then if I start doing something else, then my brain will start getting active. So take it right before, and it helped. And one of my, a lot of the athletes I work with, they tried it and they measured their sleep scores, and it worked for maybe 8 out of 10 people, So I would say it worked for most people. Some people, they don't like it. They can't take it before bed. And so you have to try and trial and error and figure it out. But I would say if you have an Oura ring, a Whoop or whatever, the best way is the objective measure of your sleep quality.
In your case, where you're having over 100 grams of carbs a day, I don't think this would work. But somebody who is on a low carb diet, or even a keto diet, but having trouble producing ketones, I could see there being a place for using exercise as a way to bring blood glucose down, bring insulin down, and help get into that state. Have you seen that work for people that are in that position?
I have not seen it myself, but theoretically it should work. I mean, there's no reason why it shouldn't, because like you said, like exercise will increase insulin sensitivity. So it will, really react to your insulin when you have a meal. So your muscles will pull in glucose based on the insulin signal because it needs the glucose for recovery. Now, if you couple that with a low carb diet, obviously that will have a strong effect on the insulin as well. And therefore you start creating ketones, when you sleep and all of that. So theoretically it should work.
Any other tactics? Somebody that's trying to get into ketosis through the diet, but they're measuring, they're getting 0.4, 0.5, 0.3, finding it tricky to get beyond that threshold of 0.5, other than exogenous ketones. Any other hacks?
So exercise is definitely one big piece of it. Some people, it might be worth measuring your hormones as well. So some people have that problem because of hormonal problems to begin with. So you might have to fix that. I don't know specifically what hormones, but you have to work with an endocrinologist or work with your doctor to figure out why your body is so inflexible that it's not producing ketones. Or some people maybe, are very efficient at metabolizing ketones that your body is not producing enough for it to be seen in the blood. Very rarely, but there have been people who are like that.
Talk more about that. I wanted to go there. So in the beginning, somebody who is new to ketosis through the diet and they're producing ketones on their own, how does that efficiency change over time? And obviously you alluded to, it's going to depend on the person.
Yep.
And this is important. If somebody's measuring and they're noticing their ketones going down, could that just be, and it sounds like it could be, the fact that their body's just utilizing them better and not wasting them?
This is what we have seen in people who are measuring people who are measuring ketone levels, who are on keto diet using P strips or breath meters. Because as I said earlier, P strips, you're usually measuring acetoacetate. Breath meters, you're measuring acetone. Two of which form of ketones, which are less stable than BHB. As your body is more and more adapted to ketones and ketone metabolism, your body will hold on to more BHB form. And therefore, you'll see less acetoacetate and less acetone as a byproduct. So the more accurate measurement would be blood ketone, because blood ketone levels are reflective of your blood BHB levels. So that's one, right? And if even when you do that, you find that your blood BHB level is getting lower over time, then double check whether there are any sneaky sources or sneaky snacks that you've introduced into your diet that may contain sugar that could spike your insulin that is causing that. Or it could be that your body is becoming more efficient, that your body is using up all the ketones before it can accumulate in the blood system. But I would say generally that's not the case. A lot of people would like to think that they're very efficient, but your body knows best. It knows how to really make sure that you have enough resources.
When it comes to ketosis and even exogenous ketones, what chronic diseases do you find are most helpful by adopting this diet and then even layering on ketones? To me, a few things that come to mind: diabetes, cancer, epilepsy, dementia. I could probably keep going, but what do you see being most beneficial?
I think the list is great. So I would go down to what's the root cause of all these diseases, like inflammation, insulin resistance, right? A lot of things it boils down to the deficiency in glucose metabolism, that your body can't take in enough glucose, or can't metabolize enough glucose due to dysfunctional metabolism. And because of that, providing ketones in there will then provide that auxiliary fuel and provide the get out of jail card, if you would, and let these organs to function as it would normally do and have the energy it needs to function without glucose. There are other areas that I didn't even know, right? That ketones could be beneficial. For example, earlier I said about the paper on kidney protection, renal protective. This study was published in animals, and then another study that's ongoing right now in Denmark as well, in Aarhus University, different group than the heart failure one, actually showed improvement in kidney health using Ketone IQ. So hopefully they'll be publishing soon. And then heart failure, obviously, we looked at it earlier. The fact that a failing heart, this is an interesting fact. As I said earlier, a normal heart would metabolize fat mainly for energy. However, in a failing heart, in people after heart attack, and the heart is essentially failing and not able to pump enough blood to your body, they actually saw an increase in ketone metabolism in the failing heart, regardless what diet this person is on. So then scientists and researchers and cardiologists figured, okay, since it voluntarily increases ketone metabolism, whether or not they're on a keto diet or on a keto lifestyle, let's give them exogenous ketones and see if they actually would like it. And it showed that they loved it, and they increased the clinical outcomes of these patients. So that's one. And then in conjunction with Alzheimer's and dementia, we're also looking at traumatic brain injury. We just submitted a grant with the Naval Health Research Center based in San Diego. I'm actually invited to talk at a symposium next February for them to look at ketones and TBI, concussion, because what we have seen is that metabolically, these TBI cases are very similar in the metabolic profile to that of Alzheimer's patients, is in that they are not very flexible in terms of energy metabolism, and they are deficit in energy, and they can't metabolize glucose as much, or they need a lot of energy in order to mitigate that damage from the concussion. So there is TBI with regards to neurodegenerative diseases, and then heart attack, obviously heart failure, with regards to diabetes and obesity. That's cardiovascular disease, and diabetes are always very much linked. In fact, if you have diabetes, you have, I believe, 4 times higher risk of cardiovascular disease. And we also looked at sleep apnea. We had a grant that almost got funded with Johns Hopkins, because they found that keto diet actually improves sleep apnea, obstructive sleep apnea. So people who snore, most of them have sleep apnea, and it affects their body's ability to absorb oxygen because there's not enough oxygen going in. So at night, throughout the night, they're getting way lower oxygen saturation than they should. And over time, it increases risk for obesity, cardiovascular disease, or even mortality. So we submitted a grant to NIH looking at using Ketone IQ for improving sleep apnea. But at the moment, we're running a pilot ourselves and then resubmitting the grant. We are also looking at fatty liver disease. So as I said earlier, some parties, out there talking about how ketonediol may be bad for liver because it converts BDO into BHB. We are actually seeing preliminary results, that it helps with fatty liver disease. So we decided to design a whole study around this and submit it to NIDDK, the National Institute of Diabetes, something and kidneys. So we're looking at improving fatty liver disease patients with Ketone IQ, which would be super interesting. We are also looking at migraine, spreading depolarization. That is a much earlier stage study. We are still looking for proof of concept in animals to begin with, and then we'll move on to human studies. And then the last grant that we are also in the process right now that has been submitted in September is bipolar disorder in with the University of Pittsburgh Medical Center. That is a very interesting study because this PI, principal investigator, that we're working with, Dr. Mary Phillips, she is a very renowned psychiatrist in the world, not just in the US, in the world. And she already has a $6 million grant from the Bazooki Group looking at bipolar disorder and solving bipolar disorder using keto diet. So she and I sort of spoken, and we thought it'd be a great idea to add ketone IQ to the mix for people who can't be on a keto diet or who can't adhere to the diet, and to really supplement that lifestyle for these bipolar patients. And metabolic psychiatry is a real thing now, and it has sort of come to light via, I think Dr. Chris Palmer from Harvard talks a lot about this a few years back when he released his book, Brain Energy. And, he was like, oh yeah, the psychiatrist community think that, he's crazy and going against all the teachings. But there are more and more evidence that it shows the psychiatric disorders could possibly stem from metabolic disorders and metabolic dysfunction.
And to me, that makes a lot of sense, tying back to early in the conversation, talking about the blood-brain barrier and the brain being unique where fatty acids can't get there. So naturally, it's going to be more prone to errors or problems with energy delivery. Ketones come in, they can get through the blood-brain barrier. It just makes a lot of sense.
The way we look at it, all these other diseases, we're like, oh, they're all related to metabolism, like heart disease, diabetes, Alzheimer's. And then suddenly we're like, oh, psychiatry has nothing. It's just genetics, or it's just the brain. It doesn't make sense, right? Like everything is connected within our bodies. So if something is wrong in your gut, something is wrong in your metabolism, something is wrong on a fundamental metabolic level, it will affect your brain to a certain degree. Now we are like just scraping the surface of understanding how it would affect psychiatric disorders.
Coming back to sleep apnea, you mentioned the potential benefit there, or even benefit you've seen. It sounds like it's really preliminary. How much of that is independent from weight loss? Because a lot of times when people talk sleep apnea, you got to lose the weight, you have all that extra weight in your neck. But it sounded like, by the way you explained it, that there's something with ketones independent of that.
That's a great question, Jesse. Like that, you hit the nail on the head. They did the analysis and they made sure that, I asked the same question too. They made sure that people on the keto diet are not losing weight per se during that study, so that they can measure the effect of ketones specifically to sleep apnea. So they managed to analyze it and isolate both independent of weight loss and independent of the diet. So the PI, Dr. Jonathan June, he was very, very, very confident that it was not the diet per se, it was the ketone per se. Because this is me coming in as a scientist, regardless whether or not I work for Ketone, I'm like, look, I also want to find out the truth here. What are the chances that it is the decrease in insulin and you fixing the metabolism rather than the ketones itself? And he's like, no, I think it's the ketones. So they did the analysis and they figured it was ketones, and that's why we were confident with the grant application. But I think weight loss is a great side effect of that. If you can, go on the keto diet, lose weight, and fix your sleep apnea, and put on muscle, and all etc. That's why not, right?
Coming back to you taking ketones at night, first off, how often are you doing that? And then tying into what we're talking about here, subjectively, somebody that's snoring or stopping breathing at night, sleep apnea, have you seen anybody without changing the diet or losing weight take a shot of ketone IQ and improve their sleep?
Yes. So the second question, yes. We have people who are very adamant in measuring their sleep and all that are usually athletes and people that we work with who are, partners who do CrossFit and generally like healthy, fit people, and they have seen acute effect of that just by taking one shot. Or like there's a speed skater, Victor Thorup. He is an Olympian speed skater, and he literally recorded a whole 30 days of taking ketone IQ, measuring his sleep and everything, and he made a whole YouTube video out of it. So you can go check it out on his YouTube. In terms of me using it for sleep, I take it every day, if not almost every day. It's just used to it. It literally sits on my desk, and then, before I go to bed, I just take 2 shots and take my melatonin and L-theanine, sleep like a baby.
You mentioned the speed skater. Now that this information is becoming more available on ketosis and ketones, products like Ketone IQ are hitting the masses. How many pro athletes, Olympic athletes, are tuned into this and using a product like Ketone IQ? And then is there any legal reasons that it's banned and they can't?
No, there is no legal reason that it is banned. In fact, we are the only ketone supplement that is NSF certified. So that is our claim to fame. We actually went out of our way to make sure that, 1, it is safe, 2, it is efficacious, and we get anything, all the NSF certification that we need for our athletes, as well as third-party testing that we often send to our researchers, collaborators, and athletes if they ask for it. We have third-party testing to make sure that, 1, it is what it says it is, and 2, it is free of anything else that is increasing, performance per se. Some supplements out there that are like, oh yeah, this increases performance, and then they put shitload of caffeine in there, and that's the actual cause of increase in performance. So that's where we are on performance. That in terms of who use it, I think you can find that on our website too. We've got Visma Lisa Bike, top Tour de France team that use it. We've got John Jones, I'm sure a lot of people know the MMA. John Jones, who was actually now part of our team now, and really actively helping us promote our launch at Target just recently. We have Olympians. We have Michael Andrews, the swimmer, also as our partner. We have Sarah Hall, marathoner. We've got Des Linden. We've got Sam Long, a lot of different triathletes and high rocks athletes as well. They're all using it.
But in the big scheme of things, you're naming a handful of people. It seems like it's not widely being used. To me, it seems like a no-brainer, and that a lot of records will be smashed when people find out about this, and maybe even combining it with the ketogenic diet.
But also remember this, in competitive sports, people don't like sharing their nutrition plans, their training plans, or their supplement plans, right? There are some people who actually actively ask us not to share how they train, how they use it, and we have to, oblige. So yes, it's a no-brainer. From our point of view, is that why isn't everyone using it? I mean, trust me, I'm working for this company. I'm like, why isn't everyone using it? It'll help me with my job and proving the science. But again, in competitive sports, that's the problem, right? Because you don't want everyone to know your secrets either.
Right. To me, it almost seems like we must be in this stage right now where a handful, relatively, of people know about it, are using it, are benefiting significantly, I would assume. And it's only a matter of time before this becomes a new baseline.
Well, it's a bittersweet spot, I think, because I think it's great to position it as like, this is like such a great supplement that is really helping people like break their plateaus and break the records and change lives, right? But then, yes, we want to be the next generation of collagen, the next generation of electrolyte, right? Where it's so ubiquitous and everyone is using it to really improve their life. Because my passion has always been in chronic diseases, because my whole PhD was in cardiovascular disease and diabetes. And that relates very much to my family too. So at the end of the day, I want everyone to use it for their own health and in whatever way they find suitable for their health, and make it as commonly as a 5-hour energy drink or a Celsius or a Gatorade. But there's no but, actually. You know what? That's the goal. That's the goal. I was gonna say, but we also want to be that special kid. But I think we're past that point now. We're past that point where we are like the premium product, where only the successful athletes and the special forces can use. Now it is at a price point where it's affordable for a lot of people, and it's available in Sprouts nationwide, is available in Target, is available in some 7-Elevens, and a lot more grocery stores. I think it's getting there, but the big piece is definitely education, which is why you and myself are doing what we're doing now, and really sharing the information that a lot of people may not be privy to, especially with regards to the studies, interpreting the studies, and with conflicting information out there, with competitors trying to, muddle the waters, and really spreading misinformation as well. So that's everything. I mean, if you're doing something right, there will always be competitors. There will always be misinformation. And that just proves that you're doing something right.
And I want to highlight too, we've been talking about ketosis as a whole, exogenous ketones, the ketogenic diet. And for people that don't have the means of getting exogenous ketones, or they just want to do it naturally, the diet is a powerful modality, and it doesn't cost you anything. You just need to start switching up your macros, and you're going to start producing your own ketones, and you're going to get the benefits we're talking about, likely additional benefits when your own metabolism is producing these and changing over time, which it inevitably will. So I'm excited about everything ketones, what you're bringing to the table, the diet, people getting metabolically healthy. It's all amazing.
That's the key, right? I often tell people, when I give a talk, when I give a presentation at conferences, I literally say, I don't care how you get into ketosis, as long as you get there and stay consistent. If you can get there via the diet, great. If you can get there via fasting, great. And if you don't want to have to diet and fast, and you want to do exogenous ketones, sure, great. Like, depending, again, go back to what your goals are, right? Use it as a tool. The ketones don't let ketones run in your life. Use it as your best friend to help you reach the dreams that you never thought of reaching.
I think a good place to end this is talking to our average person out there who is potentially overweight, metabolically unhealthy, excited about what they're hearing or seeing today. We went into high performance and professional athletes, but let's bring it back to that common person. Somebody right now who is insulin resistant. You talked about before the fact that over 90% now are metabolically unhealthy. We got into specifics of the brain, the heart, but let's talk about energy production as a whole. And somebody who is insulin resistant, what's happening there? And then as they regain metabolic health, introduce a ketogenic state or ketones, how we can provide that energy to the cell in a different way.
I love how you, like, for the past hour and a half talking to you, you are so good at painting a picture via your storytelling. I love it.
Thank you.
I can literally picture this person and the things that they are going through, because I went through the same thing, right? So I would say, if you are that person listening, first of all, go back to your basics first. It's boring, it's mundane, but you have to go back to your basics. Your nutrition, your movement, physical activity, your sleep, your stress management. Those are just basic stuff, right? But make sure you're working with someone, or you can work on yourself, look at YouTube videos or whatever resources that's available to you, use it. Improve those, right? Know what your calories should be, And if you can measure it, because it makes a lot of difference. I know a lot of people hate measuring calories, but it for me, it helps tracking. So use whatever means you can to track it, because if you're not tracking it, then you don't know, you won't know whether you are on the right trajectory or if you're doing the right thing. And then start doing it. And literally nothing stops you from doing it from today, right? And then you monitor your results, measure your weight every other day, every week. If you don't see results, try changing things a little bit, or work with somebody who can help you change things a little bit. If you have problems with motivation and productivity and getting there, try a shot of Ketone IQ. Like literally, I think now they're doing a promotion in Target or whatever, like first shot is free or something like that. Check it out. Like, or I'm sure Jesse has a discount code or whatever to try it. Use a shot of Ketone IQ to get to your workout, or if you feel like a slump during the middle of the day, use it to get through to your day. And over time, that improvement that you see will be the motivation that will feed back to your cycle and get you moving more and get you more motivated. The key is not to get bogged down on days that you fail. It's about getting up and keeping it consistent. What if one day you gave in and you ate McDonald's and you ate a shit ton of shit food and processed food? Get back up the next day, get back on schedule, and do what's best for your body. Because remember, you're not doing this because you hate your current self. You're doing this because you want to love, or you love yourself enough to want to shape your future self to not be what you are today.
Let's zoom in on this person's physiology. Hyperinsulinemia, insulin resistant. They keep on spiking blood glucose through sugar and carbs. Insulin's ramping up in the body. Talk about what's happening to the cell there, and then what happens as they apply a healthier diet and lifestyle, and they work their way back, and they restore the metabolism.
Great. So you're already insulin resistant, you are overweight, you are hyperinsulinemia. What's happening within your body is that your cells are so full. They are so full of substrates and fuel that it can't take no more. And it decided to shut down the insulin receptors and therefore causing the insulin resistance. Because the cells are saying that if I take in any more insulin, any more glucose via this insulin signal, I'm gonna die because of oxidative damage, inflammation, all of that. So in order to preserve myself as a single cell, I am going to shut down the glucose coming in. As a result, you're having high level of glucose in your blood, and that is increasing your risk of damaging your nerves. You're increasing risk of infection. You're increasing risk of developing type 2 diabetes. And then in which case, if you have type 2 diabetes and then high level glucose and infection, you are risking amputation on top of that. And it's all sort of, complications that are coming down the road. So first and foremost, you need to fix that, right? You need to reduce the sugar going into your body. And that gives the opportunity for your cells to actually metabolize what's already in there. And then over time, your cells would then normalize and be more insulin sensitive. Again, exercise is one very much proven and established way to increase insulin sensitivity. So you give your body the room it needs to regulate itself and become insulin sensitive again. Reduce your blood glucose level by ingesting less calories overall, but more importantly, less carbs and less sugar. Going on a keto diet is a great option, and because it also regulates your hunger hormone so that you are full easily from the fats and proteins, rather than letting the glucose really run your hunger hormones and let you feel hungry all the time. And then you'll start seeing weight loss because, your body is starting to self-regulate and start burning all the sugar as well as the fat, because then you are not in a state where you're building and storing. You're now in the phase where you are burning and breaking down all this storage that you don't need. And then as you ramp up the exercise level, movement, physical activity levels, as well as decreasing your calories, you will then lose all those weight and be more metabolically flexible. And that's where you start, swapping over to fat oxidation and ketone production. Increased ketone production also means increased cognitive performance, not only physical, but also cognitive. You feel clearer, you have less brain fog, and it's inevitable for you to get that motivation as well. Because as you feel healthier, you feel lighter, you feel less fatigued, you will feel more motivated. And it's funny how it works that way because, one thing will lead to another. It's the same thing the other way around as well. It's like a dominoes effect. And once you're in the right direction, everything sort of falls into place.
And for somebody out there right now feeling hopeless, feeling sick, feeling fat, there is hope. And you shared your story before. You were obese as a kid. You've turned it around. There's hope.
Yeah. No, there is hope. Genetics is just a blueprint that we're born with that we don't have choice of. But epigenetics is something that we can affect. We can affect how these genes are being expressed. Even if the genes are essentially exposing us to a higher risk of certain diseases, we can do certain things to reduce the risk by reducing the expression of these genes, because even though they are in our DNA, they still need to be expressed. And all the stimulus, all the things that we do in our lives will affect the expression of the genes and to what degree it's being expressed, and therefore affect our current state of physiology, our metabolism, as well as our psychological state.
All right, Latt, that's a great place to end it. I really appreciate you taking these complex scenarios, breaking them down in a way we can understand. Thank you for coming on. I appreciate you. We're going to link up Ketone IQ with the discount, your social media, the Ketone IQ website. Thank you.
Thank you so much for having me. And thank you so much for creating all these unique scenarios that a lot of people out there can really relate to, and allowing me to really exercise my brain to think of a scientifically proven, evidence-driven, and also practical way of solving these problems. So I had a great fun talking to you. Thank you.
Now that you're done, you're going to want to stick around here and catch this other incredible episode. You don't want to miss it. I'll see you over there.
Your physician is never going to care this much. They're not going to study you this much. You have to study you this much. That morning fasting blood sugar, when it only gets to 95 in the morning, you got problems. That's not normal.